However, we are talking approximately loads of thousands and thousands of instances the mass of the solar. But it is a black hollow, so it is small for that a whole lot mass. The Sun goes around a black hollow inside the constellation Sagittarius on the middle of the Milky Manor galaxy. Scientists have made a jaw-dropping discovery right on the coronary heart of those enigmatic cosmic beasts. They have unearthed something thoughts-blowing and terrifying inner a black hollow, challenging the whole lot we thought we knew approximately these cosmic wonders. Buckle up because we're about to unveil the amazing secrets lurk within a black hole's mysterious core. Are you curious to understand greater? Let's dive in. Black holes are a captivating phenomenon. In accordance to a first-rate scientist named Albert Einstein and his idea of widespread relativity, the floor gravity is so high that you can't break out it, even at the rate of mild. You're for all time trapped. Gravity is not a pressure like magnetism or pushing and pulling. Instead, it's an end result of how space and time are curved or bent by items with mass and power. Believe you have got a large object like a celebrity in space. It has an full-size quantity of mass and energy. This causes a deep dent or curvature within the fabric of space and time round it. This curved area and time are what we name a gravitational field. The extra big and energetic the item is, the stronger its gravitational subject and the deeper the dent it creates. Now, preserving that concept in thoughts, allow speak approximately black holes. They may be a number of the most intense objects in the universe, with unattainable amounts of mass and electricity packed into a tiny area. They have got a lot mass that their gravitational discipline will become rather extreme. This excessive gravity creates a fantastic deep and really robust dent in the cloth of space and time. Here's wherein things get virtually crazy. The gravitational pull close to a black hole is so highly sturdy that it paperwork what we call an occasion horizon. The event horizon isn't some wall. It's just area transferring easily through and across the occasion horizon is like an invisible boundary or factor of no go back. As soon as something, like an unfortunate spaceship or even mild, crosses this boundary, it may by no means break out the black hollow's hold close. It's as if the black hollow has an invisible force discipline that holds everything inside, including mild, that's normally the fastest factor inside the universe. Just to emphasize how outstanding this is, believe you are shining a flashlight. The mild being tour actually rapid, approximately 300,000 kilometers per second. However, if you were one way or the other inner a black hole, the speed you will want to get away its clutches would be even quicker than the velocity of mild. It is impossible in keeping with our present-day know-how of physics. So, any mild that enters a black hole will become trapped for all time, unable to interrupt loose. Light into the black hole, light coming from farther away, gets bent around it. So, while we speak approximately a black hole, we can't overlook approximately its mysterious boundary referred to as the occasion horizon. It's like a factor of no return for anything brave or unfortunate enough to challenge throughout it. As soon as something crosses that boundary and falls right into a black hole, it is a one-way ride with no turning lower back. The event horizon is not something you can bodily touch or see. It's extra of a mathematical concept that tells us where we will no longer examine what's going on. You might be thinking, how large is this occasion horizon? Nicely, all of it relies on the shore's chilled radius, the mass of the black hollow itself. The extra large a black hole has, the larger its occasion horizon may be. Scientists came up with a method to calculate the radius of the occasion horizon and named it the shore's chilled radius after an astronomer named K.L. Shorelines Chi, who figured it out back in 1916. To discover the SCHZ chilled radius, you divide the mass of the black hole via a steady that involves the gravitational constant and the rate of light. For example, if we had a black hole with a mass 10 times extra than that of our Sun, its occasion horizon could have a radius of approximately 30 kilometers. In the coronary heart of a black hollow is what is called the singularity. All of the mass and energy of the black hole, irrespective of how thoughts-bogglingly massive, is squished and compressed into an infinitely tiny and dense point at the middle. We call this point the singularity. It's like a cosmic heavyweight packing an exquisite punch of gravity and curvature. In truth, the singularity has endless curvature and infinite gravity. That's pretty charming, but here's the seize. Our knowledge of physics starts off evolve to collapse when we try to make feel of what happens on the singularity. We sincerely don't know what goes on there. It's as if the laws that govern our universe take a smash or move on excursion, leaving us scratching our heads in marvel. Scientists are nonetheless exploring this enigmatic territory, hoping to find the secrets and techniques hidden within the heart of black holes. And how do black holes come into lifestyles? It all starts with the existence cycle of a massive big name. Those stars are like cosmic powerhouses fueled through supernuclear fusion reactions going on deep inside their cores. Imagine these reactions as an incredible cooking display. A specific nuclear response that powers the sun is fusion. Fusion of hydrogen into helium. You're taking hydrogen atoms, you ram them together, and what's left over is a helium atom, where hydrogen atoms integrate to form helium atoms, releasing an extensive amount of energy in the manner. So long as the famous person has enough hydrogen gas to hold the fusion going, it remains strong. But stars are grasping, and they want to keep the fusion celebration going. Once they run out of hydrogen of their middle, they get a little innovative. They begin fusing heavier elements like helium, carbon, and oxygen. Each fusion reaction with heavier elements produces less strength than the preceding one. To compensate for this, the megastar has to work harder and burn faster, turning up the warmth to preserve its delicate balance. And sadly, every star's adventure must come to and give up. The megastar reaches a critical point wherein it could no longer fuse any extra elements. At this moment, something awesome occurs. The celebrity's center collapses under its very own tremendous weight, like a wonderful implosion. And there you have got it. A black hole is born. While the center collapses, it bureaucracy the part of the black hole known as the singularity, which we mentioned earlier. This singularity holds all the star's mass and power in an exceedingly tiny area, creating an intense gravitational pull that no longer even mild can get away. It's like a cosmic vacuum cleaner, sucking the whole thing into its gravitational embrace. When a celebrity is drawing close the give-up of its life, what occurs subsequent relies upon on its length or, in different phrases, its Massachusetts allows ruin it down into 3 stellar weight classes. First up, we've stars that are smaller than about 3 times the mass of our solar. Those stars are in for a transformation. As opposed to going out with a bang, they turn out to be something called a white dwarf. It's just like the superstar decides to retire gracefully inside. It's a dense ball made up of carbon and oxygen atoms, which continue to emit light as residual warmth. Now, if the star happens to weigh between approximately 3 and 20 times the mass of the solar, get prepared for an explosive spectacle. A supernova. These stars exit with a massive supernova bang. The center of this superstar, amidst the chaos of the explosion, undergoes a dramatic collapse. It becomes a splendid dense ball referred to as a neutron big name. Consider squeezing up to 2 times the mass of our sun right into a tiny sphere with a radius of handiest about 10 kilometers. Now, if we're speaking approximately a real heavyweight superstar, ones that weigh more than approximately 20 times the mass of the solar, the stars additionally explode in a supernova just like their slightly lighter opposite numbers. But the core of those significant stars has an exclusive destiny. It collapses under the load of its gravity, and it doesn't forestall there. The gravity will become so particularly excessive that the middle shrinks all the way down to 0 extent and infinite density, which once more outcomes in the start of a black hollow. Black holes have multiple kinds. We have stellar mass black holes, those that shape from massive stars nearing the give-up in their stellar trips. They typically have loads beginning from sometimes to several tens of instances that of our reliable Sunday. Stellar mass black holes are truly pretty commonplace in our galaxy and different galaxies out there in the vastness of space. Now let's shift our gaze to the gigantic supermassive black holes. Cosmic behemoths are the true giants of the black hollow own family. They boast masses which might be hundreds of thousands or even billions of instances extra than that of the solar. Photo them as the masters reigning on the centers of most huge galaxies, such as our very own Milky Way. These potent black holes are thought to have shaped all through the early stages of the universe, born from the collapse of massive clouds of gasoline and dirt or from the merger of smaller black holes. Their presence greatly influences the evolution of galaxies, shaping the formation of stars and planets that dance around them. Now, we encounter a rare breed known as intermediate mass black holes. These elusive creatures sit down proper between the stellar mass and first-rate big variatities in phrases of mass. They're just like the middle kids of the black hole-own family, truly mysterious and now not normally noticed. Their starting place is still a piece of a puzzle. However, scientists speculate that they'll have fashioned from the crumble of highly massive stars during the early cosmic eras or from the union of stellar mass black holes in dense and bustling star clusters. Lastly, we've the fascinating primordial black holes. Those are the capability relics from the very beginnings of our universe, born quickly after the huge bang itself. They emerge from fluctuations inside the density of remember and electricity in the course of those cosmic early moments. Primordial black holes are available in a wide range of sizes, from minuscule ones with loads only a fraction of a gram to massive ones lots of times heavier than our solar. It's vital to be aware that whilst they're captivating in concept, primordial black holes continue to be hypothetical and have yet to be at once found. Black holes have another interesting thing: their rotation. For instance, there are the Skees-chilled black holes. Those are the easy and trustworthy ones. They don't spin. Think of them as the calm and regular black holes of the bunch. They're described through the Schwarzschild solution, a mathematical description in Einstein's theory of popular relativity. These black holes have a pleasing horizon, which is sort of a boundary that marks the point of no-go back, and a unique point at the center called the singularity. It's like a unique dot with a giant gravitational pull. In the identical way, if you fall in across the event horizon of a black hollow, you are going to the middle. These ones are all approximately that spin. See, black holes are defined via the C answer in standard relativity. They have an oblate or slightly flattened occasion horizon and a singularity that takes the shape of a ring. The rotation of a curved black hole creates something called the ergosphere. This area across the black hollow is sort of a cosmic whirlpool in which area and time get dragged along via the spinning black hole. Now, let's meet the common black holes. Those are the rock stars of rotation with a bit greater something. They no longer most effective spin but also deliver an electric-powered rate. Kiram and black holes are described by way of the common answer in well-known relativity. They proportion many similarities with black holes like their oblate occasion horizon and ring-like singularity, but the electric phi provides a twist to their tale. The event horizon and singularity get a bit distorted through the electric discipline. Scientists have observed ultramassive black holes. An ultramassive black hole is a virtually awesome cosmic heavyweight. It hints the scales at extra than a whopping 10 billion times the mass of our trusty sun. We're speaking about a black hollow that's so massive its gravitational pull is unimaginably robust. Anything that ventures too close to it would be in for a wild trip. How did we even discover those cosmic monsters? Well, a collection of sharp-eyed astronomers from Durham College in the United Kingdom took on the task. They utilized a slicing facet approach called gravitational lensing. In keeping with Albert Einstein's superb concept of preferred relativity, huge gadgets like galaxies or clusters of galaxies can bend and deform the path of light.